Hello students, I am Rahmat Ali from Indirapuram Public School. In our last lecture, we discussed about the law of conservation of linear momentum and its applications. Today we will discuss friction and its effects. Friction. In Newton's law, we have learned that any object cannot change its state on its own. Then, why does a sliding body stops after covering some distance? Why does a rolling ball stops after covering some distance? Is it violation of law of inertia? Answer is no. Then why does it stops? Is there any external force acting on it? Yes, it is due to an external force acting between the surfaces in contact. This is called force of friction. Force of friction always opposes relative motion between the two surfaces in contact. What is the origin of friction? According to the old concept, friction is due to the roughness between the two surfaces in contact. If surfaces are rough, then friction is high. If surfaces are smooth, then friction should be small. But practically we have learned that if surfaces are extra smooth, then force of friction increases. Then what is the modern view? In modern view, we have learned that the force of friction is due to intermolecular forces between the two surfaces. What are the different types of friction? Number 1, static friction. Number 2, limiting friction. Number 3, sliding friction. Number 4, rolling friction. Let's study one by one all of these forces. Number 1, static friction. If an object is at rest and we are applying some force on it, but the body is not moving, then the applied force is balanced by the force of friction. In this situation, the force of friction is called static friction. If we increase the value of applied force, then we observe that the force of friction also increases. If we keep on increasing force of applied value, then at one stage the body is at the verge of motion. That means the body is just about to start. At this instant, the force of friction is called limiting friction. Now, if we increase the applied force any more, then body will start moving. Beyond this value, if force of applied value is increased, then body will start sliding, and in this situation the force of friction is called sliding friction. Let us draw a graph. On this graph, if we represent the value of applied force and force of friction, then initially we get a straight line inclined to the x axis. This straight line indicates that the force of friction is balanced by the applied force, and the force of friction is called self-adjusting force in this situation. Hence, we can also say that the force of sliding friction is self-adjusting force. At the top of the graph, we observe there is a small kink and the graph slides down. In this situation, the force of friction is called limiting friction. As the declining value is there and beyond the declined value, the graph becomes a horizontal line parallel to x axis. This indicates that the force of friction is now constant, and this force of friction is called kinetic friction. As the graph is now a straight line, so it indicates that the force of friction is constant and the kinetic friction has attained its constant value. Laws of limiting friction. Now we will study what are the laws. Based on the experimental study, we observe that force of friction is always in the opposite direction of applied force. If the force is applied towards right hand side, then force of friction is in the left hand side. If force is applied in the left hand side, then force of friction will be in the right hand side. This proves that the force of friction is always opposite to the applied force. Law number 2, force of friction is independent of area of contact between the surfaces. Let we have a cuboidal shape. All the three surfaces have different area. If the maximum surface area is kept on the surface, applied force is there and we calculate the force of friction. Similarly, we change the area of contact. This time the medium area of contact is there between the body and the surface. Again we apply the force and notice the force of friction. This time we calculate that the force of friction is same because the applied force required to move the body is same as in the previous one. In the third case, again if we change the area to the minimum area of the cuboid and apply the force, then we will find that the applied force is same. It proves that force of friction is independent of area of contact between the surfaces. Force of friction depends upon the nature of the two surfaces in contact. It means if same body is kept on different surfaces, then force of friction is different. Practically we observed if a block of wood is kept on wood, then force of friction is say F1. If the same block is now kept on the steel, then force of friction is say F2. And in the third case, if the same block is kept on the surface say copper, then force of friction is F3. Practically we observed that in all the three cases force of friction is different. It proves that the force of friction depends upon the nature of two surfaces in contact. Force of friction is directly proportional to the normal reaction offered by the surface. Let us say we have a body of mass m. In order to move it, it is to be pulled by a force P1. The normal reaction offered by the body to this given body is say R1. If we put another block on the given body and we want to move it, then we will have to apply force P2. This time the normal reaction is R2. In the third case, if we put one more block on the given two blocks, then in order to move the combination of three blocks, we will have to apply a force say P3. This time the normal reaction is R3. As in all the three cases, normal reaction is increasing one by one and applied force is also to be increased, then we can say that the force of friction is directly proportional to the normal reaction. So, we can say F, the force of friction, is directly proportional to the normal reaction R, putting a coefficient of proportionality mu. So, we get F equals to mu into R. Let us solve a numerical based on the concept. Let we have a body of mass m, say m equals to 5 kilogram. If a force of 10 Newton is applied on it and the coefficient of friction between the two surfaces is 0.3, then we have to calculate acceleration in the body. Let us solve it. Weight W equals to m into g. M is 5 kilogram, g is 9.8. So, we get W equals to 49 Newton. So, the force of friction F equals to mu into R. As the normal reaction is equal to 49 Newton, so the force of friction F equals to 0.3 into 49. The value becomes 14.7 Newton. As the applied force 10 Newton is less than the force of friction 14.7 Newton, so the body will not move, and we say the situation is of static friction. Now, say a force of 20 Newton is applied on the given body, then the applied force is more than the force of friction. applied force is 20 Newton, force of friction is 14.7 Newton. So, body will move. We know acceleration A equals to force upon mass. So, A equals to F upon m. So, the net force acting on the body will be 20 minus 14.7. So, acceleration A equals to 20 minus 14.7 divided by 5. So, acceleration A equals to 5.3 divided by 5, which comes to be 1.06 meter per second square. Acceleration of a body down a rough inclined plane. Let a body of mass m is kept on an inclined plane at an angle theta. So, weight of the body W equals to m into g. It will be acting towards the center of earth, that means perpendicular to the ground. Resolving this force due to weight into its rectangular components, we get mg cos theta and mg sin theta. Mg sin theta is parallel to the plane and mg cos theta is perpendicularly downward to the plane. Due to mg sin theta, body is supposed to slide down. That means body is tending to move in the downward direction. So, force of friction has to oppose it, and force of friction will be acting in the upward direction. Normal reaction offered by the surface to the body R is equals to mg cos theta. According to the laws of friction, F is equal to mu into R. Here mu is the coefficient of friction. Substituting the value of normal reaction R, we get F equals to mu mg cos theta. If mg sin theta, the downward force, is greater than the force of friction, then body will accelerate in the downward direction. If acceleration of the body is A, then net force ma will be acting in the downward direction. So, we get ma equals to mg sin theta, the downward force, minus mu mg cos theta, the upward force. Taking out mg common from right hand side, we get ma equals to mg bracket sin theta minus mu cos theta. Cancelling m from both the sides, we get a equals to g sin theta minus mu cos theta. Rolling friction, the last type of the force of friction. Force of friction acting on a circular body which is rolling on a surface is called rolling friction. It arises due to some deformation in one of the two surfaces in contact. You might have seen a car parked on the road. Its tire gets deformed a bit. This deformation is responsible for rolling friction. Friction is necessary evil. It is very commonly known that force of friction is necessary at many places, and force of friction also harms us. For example, walking, stopping any moving body, writing on the copy, etc. is possible due to friction. If friction is not available, then walking is not possible. Stopping any moving body is also not possible, and we cannot write on the copy. For example, if you spread some oil on a copy and start writing on the copy, then you will not be able to write on it. Reason is force of friction is very less. So, we can say friction is necessary. Friction produces some undesirable effects like wear and tear in machines. Energy is lost in doing work against friction. So, we can say friction is an evil. So, depending upon the requirement, we have to either increase or decrease friction. Wherever we need friction, we will have to increase its value, and wherever we do not need force of friction, then we will have to reduce its value. Some methods of changing friction. If I want to increase force of friction, then I will have to select those metals or those substances for which the value of force of friction should be high. If I want to decrease force of friction, then there are various methods. Number one, streamlining. That means we need to give the shape of the body in such a way that the force of friction should be minimum. For example, the shape of the boat is an example of streamlining, and that particular shape of boat is to minimize the friction because of liquid. Another method is lubricating. You might have seen a mechanic applying some lubrication, applying some lubricant oil on the chains or on the moving parts of a machine. This lubrication helps in reducing friction. Today we discussed friction, its effects, some methods to increase friction, some methods to decrease friction. In the next lecture, we will discuss circular motion, we will discuss banking of road, we will discuss what is the need of banking the road, and some examples, some numericals based on the concept. That's all for today. Thank you.